How many people here build with PHP? You can just raise your hands. How many people here build with JavaScript? How many people build with something else that I haven't mentioned? Okay. Um, I will be talking about grounding Gen AI and building honest AI applications. Is anyone here actually building with generative AI? Okay, very impressive. Who has just come across the term generative AI or really wants to learn? So no one's new to this. Are you new to it? Okay, a couple hands. Okay, thank you for engaging with me like that. Like I said, I'll be talking about building generative AI, or grounding generative AI rather, and building honest AI applications. I'm Daniel Phiri, a developer experience engineer at a lovely Dutch company called Weaviate, which I can very proudly say is one of the biggest infrastructure AI companies in the Netherlands. You can find me anywhere online at Malgambis. So that's Blue Sky or LinkedIn or whatever. So as a developer experience engineer at Weaviate, we see a lot of people building really interesting applications with generative AI, ranging from RAG pipelines like we saw in the first talk to chatbots for customer service in the financial industry or the e-commerce industry. And a question we always find ourselves asking is why do large language models lie, right? Or how do we get rid of this habit of large language models, or fatal flaw, as some people might say, to lie, right? And so I'll give you a bit of a history lesson to sort of show how we got here. A couple years ago, we had what I like to call the rise of the large language model. So we had transformers, this revolutionary technology come into play, which brought about applications like ChatGPT through GPT-3, Claude Anthropic, and of course, the latest we've seen with reinforcement learning was DeepSeek, right? But this rise of the large language model brought about the age of hallucinations, right? And a really funny example is this sort of vicious cycle of people generating content for these language models learning from this, and then that became the content that we start to see. So you have a very funny story of someone searching something on Google, basically how or whether, asking whether eggs can melt, and someone maybe to make a joke out of it, answered on Quora saying, yes, you can melt eggs. And then a large language model used that training data from Quora to sort of build its corpus and say, okay, I guess eggs can melt. And now when you ask ChatGPT if eggs can actually melt, it says yes, but essentially that isn't true. But these are like, it's comedic at best, right? But for a lot of industries, you have, like the financial industry, this is a behavior that you absolutely do not want to have. You don't want any behavior or any untrue information being passed on to your customers in a very critical industry, right? And so this sort of highlights a couple problems. Clearly, I don't know how to count. So the first being out of date data, right? These large language models have a training limit. When they're trained to a specific time. So large language models like Claude 3.7, for example, if you're staying up to date with your language models, I think was trained up to data from October 2024. So anything that happened beyond that is not included, right? And anything you would ask something like Claude beyond 2024 October would be a lie, technically, because it doesn't have that information, right? It's also really hard to reference the sources of these language models because they have this huge amalgamation because of the way transformers work, of data, and it basically predicts what the next item might be. And then there's also the question of security and privacy. More important, I think, in the European context with legislation and things like GDPR, where you're putting all your data, possibly sensitive data, in the hands of these corporate giants, possibly not even stored on the European continent, or wherever your data sovereignty is important to you if you're outside of Europe. So those are some of the problems that this highlights. And the previous speaker mentioned thinking about large language models like research students, right? They're very confident, and so they come up with things when they don't want to. And we can also think of this as exams, right? You're writing an exam. I think most of us have written an exam at some point in our life, right? When it's a topic we somewhat know about, but don't necessarily know the answer, we can circle around because we know the vocabulary, we know the right things to say. We could be somewhat confident, and we try and trick the person who's marking our exams into thinking we know what we're talking about, but it's absolute. It's an absolute lie, right? And so you can sort of think about this interaction with large language models as an exam. So we make things up, even though we don't know the answers. And an answer to this question of how do I solve this lying problem is an analogy of an open book exam. So this is how we solve this lying problem of large language models. So essentially, if you're in an exam and you have an open book exam about physics, you say, I'm asking you this question about theory of relativity. This is a physics book. Only answer questions off of the content in this physics book, right? It sort of makes it easier for you to not lie, and you can actually reference that physics book to answer your exam. And so what this solves is it gives us the ability to update the amount of information large language models are exposed to. It also gives it more contextual data for whatever actual application that we're building, and we have more control over where exactly this data goes. So what I just explained is a concept called retrieval augmented generation. We've had a couple of speakers talk about it, and I'll sort of zoom out from a very narrow use case for one specific company and talk about how we deal and how we manage retrieval augmented generation as an infrastructure company. Right, so RAG makes things like Verba possible. Verba is our demo. You can take a look at verba.weaviate.io. Essentially, this helps us interact with Weaviate information from a large language model. I'm having a bit of a problem with the conference Wi-Fi from when I was testing, so I might not be able to properly demo this, but I'll do my best to do it as quick as possible. So essentially what this does is sort of the interface that you're used to. I've trained this, or rather exposed this model to questions about Weaviate. And so I will show you Mistral here and say, we just released something about blockmax. Blockmax in Weaviate. What is that? So this is just a very random answer. And so I'm asking Mistral. And Mistral actually has the answer, which is incredible, because behind that, it has the ability to do web search. And so you can see exactly when this happened. Weaviate version 1.29, which is really, really fun. But you have no way of sourcing where this came from, right? And so that's the idea here with something like Verba. So I'll say, blockmax in Weaviate. What is that? And so you can sort of see, oh, this is really interesting. We haven't updated the corpus. But essentially, if we did have that, I will go to our actual website, which is a bit more updated here. I'll search a bit. Blockmax in Weaviate. What is that? Right. So we can see the actual answers that we have. Clearly, we need to update that demo. But the really important thing here that we get is the references, the actual references and the answers that power this answer, right? So we didn't have that in the Mistral model. So we're sort of working out of this black box. And in our sort of AI docs demo, we can actually see video content, blog posts, and click on things that show exactly how a technology like this works. And so this is the power of RAG. This is a diagram to sort of illustrate the flow of things. We have this layer where we have our documents, we index them or import them into our application, and then we use an embedding model to create these vector embeddings. We've talked about vector embeddings. We'll go a little bit deeper into vector embeddings and how they support a technology like RAG. We store those in our vector database. And then we use these as context. Whatever response we get from our interactions with this vector database, we augment that into our prompt. We'll get into what prompting is as well. And then we have a large language model generate an answer. So when we asked a question, like you saw in the previous demo, we got all the context related to blockmax, for example, and then we gave that to the large language model, and then that's what it used to sort of answer our question. And so this is what we'll be looking at RAG in these 3 simple steps: retrieval, augment, and generation. And so the first step usually when you think about RAG or RAG system is the retrieval portion, where there's an embedding model and there's a vector database. A lot of people like to put a huge importance on retrieval because the quality of retrieval defines the quality of data that goes to your large language model. So retrieval in a traditional sense, the way most of us do it is a sort of search problem, right? We have a subset of things that we want to look for, we query a data source for those things, and then we send back the most relevant. The problem is retrieval and the basic or sort of the base of retrieval is built on a traditional search system, which essentially does keyword matching, right? If I search something like accomplished poets, I do a keyword match and get items that are related to accomplished poets, right? But how can we actually get better than a simple keyword match? This keyword match doesn't necessarily understand the context of our information. And so I have a really nifty demo here that I've built using Next.js and Java and Next.js and Weave8 essentially, where we have a vector search application, and we've indexed a bunch of Wikipedia data. So we scraped Wikipedia articles, and we got the title, description, the URL of Wikipedia items. We indexed them with an embedding model and stored them in our vector database. And so on the basis, we want to be able to at least run some sort of keyword search. So I will show you exactly what that looks like. In this actions function, if you aren't familiar with Next.js, just think of this as a function to make a search. And we're using the Weave8 JavaScript client here. And so here you can see we're running a query. And I'll change this query that we're running to a BM25 or best match 25 query, which runs keyword searches essentially, which is what I was talking about. I'll refresh this, and I will make a request for anyone shout something random that you want to look for on Wikipedia. Don't worry if you're not feeling creative. Cheese. Nice. So cheese is a very nice query because clearly we can see a lot of cheese results showing up, yes? But I would love a more natural query, right? Like, what do you want to know about cheese? Or a specific type of cheese?
Does it smell bad?
Okay. Does cheese smell? Or why does cheese smell, right? I like this. Okay. So why does cheese smell? So in Europe, cheese analog is used, blah, blah, blah. So we get a lot of information. But do we really get the answer on why cheese smells? I've sort of looked through all of this, but I can't really find an answer to why cheese smells. And essentially, this is because we're using a keyword match, right? We asked, can we do better than a keyword match? And the answer is yes. We'll change this to a near text, which is essentially a vector search. And let's see what we get. So we'll copy this and refresh. And let's see what we get back. Doop, 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 doop. So you can sort of see that we're starting to get more nuanced responses, right? We're not just getting responses about cheese, but we're getting responses about things that smell. Yes? Or am I making that up? But you can sort of see here we have a strong must-see taste in Japanese food. And so there's an understanding here that I'm trying to find out why things smell. And that's the idea behind these contextual queries. And what's behind that is vector embeddings. I'll give you a brief explanation on what vector embeddings actually are. So essentially what we get is we have a bunch of data. We have a machine learning model called an embedding model. And it creates this array of numbers which abstract real-life information. And so you can sort of think of each array as a property. How you would describe a chair, for example, right? This first property is this chair black? Does this chair recline? Is this chair comfortable? Is this chair sold at this store? So all these machine learning models have these abstractions for how they can understand real-life information, real-life data, and they store this in a vector space. Now, this vector space has this property where all similar items tend to be grouped towards each other, because these vectors, you can sort of think of them as coordinates. And the idea of representing numbers, or rather using numbers to represent meaning, isn't necessarily foreign. I asked what we're all building with, and I think we've all at some point experienced the RGB system of rating, or rather categorizing or describing colors with the amount of red, green, and blue you have. And so you have a ranking of 0 to 255 for how much red, how much green, or how much blue a color has. And so that's essentially what large language models, or rather embedding models, do at a much larger scale. They sort of abstract real-life information using machine learning models. And so when you hear vector embeddings, that's exactly what you're dealing with. So we have this vector space, similar items grouped next to each other. We abstract real-life information. And so we want to make a search, right? We want to have more contextual search. So how does this work? We have a search term, accomplished poets. We put that through our embedding model, and we have a query vector for this query search term. And then we place this query vector in our vector space. And remember this property of similar items being really close to each other. We look around, and we run distance calculations. I won't necessarily get too deep into what these distance calculations are, but essentially we send back the most relevant items. These relevant items happen to be the ones that are close to my search query in this vector space. But how do we get better than this, right? One of the speakers talked about how semantic search or vector search tends to be not as accurate as we want it to be, right? The answer to this is hybrid search. How do we actually integrate hybrid search? We'll go back to our code here, and we'll replace near text with hybrid. And let's see how much more accurate our requests can get. So we said, why does cheese smell? And boom. So now we start to see things about cheese. Much, much closer to cheese. So we still have cheese analog. And also, by the way, I haven't scraped the whole Wikipedia. If we did, I would probably have an answer. I only have about 10,000 objects. So that's also one thing about vector search. It really does matter about the quality of the data you're working with. Like I mentioned, it sends you the most relevant item in your database. It doesn't look outside of that. So you have to actually have something related for it to send it back. But that's where a lot of other things, as I'll talk about a little later, will come in. So what we just did was a hybrid search. How does that exactly work? It mixes the best of both worlds. So we have vector search and we have keyword matching. And essentially what this does is it makes two searches, one vector search, one vector search and one keyword search. It has individual responses from each, and then uses a fusion algorithm to sort of grade what type of results you want. In Weavate specifically, we have two fusion algorithms, reciprocal rank fusion and relative score fusion. Essentially, these have their own ways of aggregating this data that you have and then giving you something more contextual. Of course, these algorithms depend on the type of data that you want to work with. One algorithm works better with financial data, one with a large corpus of very accurate text. One is, of course, more permissive with multilingual, and one isn't. So all these things are tweakable, and essentially these are all things that you can change, either via the API. We have a REST API, or you could sort of say fusion type and change exactly what that is. So you can say ranked fusion, but also you might want to tweak how your hybrid search works. So you can change the alpha of your hybrid search to 0.1, which is more like a keyword search if you want more a keyword leaning, or something like 0.9 if you want something more semantic. So all of this is really flexible. Essentially, the goal of this is you want to be able to get more accurate responses, because the more accurate responses, the more accurate that generation and context you give to this large language model is. And so these are some of the ways that we're seeing people improve their hybrid search as they're dealing with this context. All right, so how do we get better than this? We want to improve our pre-retrieval, right? So the idea of chunking, or the concept of chunking, is something that might be new to people, but essentially it's taking items and breaking them into like super cohesive pieces. We've seen this RAG diagram sort of as a step zero. We want to improve our ranking. We've already seen how we can get the best out of our retrieval, but how do we improve our ranking? And so the first concept I want to talk about is fixed size chunking, where we get our data and we cut it up into fixed sizes. So we can say, I want a chunk size of 35 as is seen in this example. And so after 35 characters, it creates a chunk. And then you have some overlap, so there's some understanding between each chunk. And all of these things are very tweakable. The second one is character splitting. So depending on the type of data you have, you might want to split characters or a chunk of text after a specific character. This could be a new line. This could be a full stop. This could be a comma. This is really, really useful if you're chunking things like code, for example, where maybe in HTML you want to split characters after a section tag or a div tag in specific languages, after maybe a function definition, or something super similar. And so chunking really helps you get the actual meaning behind your data. And then the next thing I want to talk about is that augment portion, right? We've sort of seen how search works, but in this demo, we haven't seen how RAG actually works. The next item I'm going to talk about is the idea of prompting. So when we interact with a large language model, we're specifying inputs that can guide our language model to the desired output that we want. And so in this context, let's actually build a RAG pipeline. So I have another function here that my front end calls. I'm fetching my Wikipedia data like I showed, and now I am using my generate function in Weaviate. So essentially Weaviate does this work for you. You define different language models at import time. So I have an import script here that I run. And essentially what I'm using here is a cohere vectorizer, specifically a multilingual vectorizer, which means I can make searches in multiple languages. And then I'm using a OpenAI model. I could define the specific OpenAI model, but by default, I'm using GPT-4o. And this is my generative module. So here, when I say generate, essentially what I'm doing is I'm making a hybrid. So we want a better search. So I'm making a hybrid search. And I'm passing the results of that hybrid search as context to my large language model. And so essentially, here's where we do our prompting, right? So we have a desired output. So we want to know why cheese is smelly, right? And so I have a prompt here that says, you are my teacher, guide me through the answer to this question. And I will paste that here. Is that the right format? It is the right format. I just need to get rid of this. So my question will come here. I'll search why is cheese smelly, and I could define. And I could also like say, if only give me an answer if you know. An answer if you know. If you get information in the context I give. Okay, so let's save that, and we'll navigate here to our RAG. So we have a RAG. We have a RAG page. So RAG with Weaviate. So why is cheese smelly, right? Yeah. Why is cheese smelly? Takes some time, of course, because there's interaction with the language model. So cheese can be smelly due to the process of fermentation used to blah, blah, blah. We have an answer, right? But really important, we can see what things, or rather, what data informed this answer. And so we can see actual Wikipedia pages. So I could also say, of these cheeses, which one is more likely to be smelly, right? And so the idea here is you can tweak the behavior of this through prompting. So it says, based off the information you provided, the more likely to be smelly would be Parmesan cheese or Emmental, as they are added to Mornay sauce, a variation of bechamel, blah, blah, blah. But you can sort of see all the things that were used. We could ask any sort of questions. Why do we have mascots in the Olympics, for example? But the idea here is that augment process is getting that context, really important, that context here, which is the results from our hybrid search queries, super accurate type of search, and then putting those together with a prompt that we just put in our backend. You could have this prompt come from your front-end application, your client application, and then have more accurate, honest answers from your language model. So that's the idea here behind prompting. We are getting context from our searches, and then we're getting the actual search question that we have, and then putting those things together, and then sending that to the language model. But are we here yet? Do we have that RAG, or rather like honest thing that we were looking for in our interactions with large language models? No. We have generation. There's a couple things you might want to change on the generation side of things, right? You get that context, you have the language model generate something, and then you pass that to the user. There's a couple different things, and I haven't necessarily gone through what that workflow looks like. And so essentially we make our query, why is cheese smelly? Or which of these cheeses might be the smelliest? We retrieve all cheese information, or cheese-related information about smelly cheese, cheese that doesn't smell, or generally anything cheese. We get that information and we pass that to the language model here. And we say, hey, I have all these cheeses, possible cheeses that could smell, maybe don't smell. Which one do you think is the most smelly based off the information that has been used to describe this cheese? And then now the language model can say, okay, I just have this information to go through. And based off this information, I'll reason within my capabilities as a model and parse this text and say which one is the most smelly, and then actually generate something that is more relevant to me. And so here in the generation part, you have a big choice in terms of what models you can use. Specifically in Weaviate, we let you interact with any sort of model. So any model that exists, you have the option to interact with that. But also, we have this very nice description of all the model integrations that we have like first-party support with. But we're open source, so you can add your own models if you want to. And essentially, if I want a deep thinking model, for example, through something like DeepSeek, if you're interested in doing that, we have integrations with Ollama, for example, and so you can run these models locally or deploy them somewhere. We have Hugging Face, of course, as well. And like I mentioned, I was using OpenAI's models. So you have that choice of, hey, what sort of model do I want to use? What sort of model or what sort of behavior do I want my system to implement? We got mentions of how the Mistral model, for example, is really good at structured outputs with function calling. So there's all these decisions that you have to make when you're thinking about what output or what behavior do I want my model to have. And we are at WebDevCon after all, right? And I did explain, I'm sort of building this with a Next.js project where I have some sort of client interaction and I have a backend interaction with a node process. And this is sort of the behavior that we want to promote because in a lot of the applications we're seeing people build, it's a lot of mission critical information in different industries ranging from financial to the medical to e-commerce. And so essentially, we don't want you to be making all these requests natively from your client application. You sort of have to have an intermediary in whatever application you're building. Have either a node, or if you're using another language, we have REST API support. So you can use and make calls to a REST API and build that functionality into whatever language you have. And that's how you interact with that database, either deployed on our cloud process or your own open source version on your own infrastructure. And you can have access to a lot of these or this functionality that I just described. So I have a lot of demos for everything that I showed. You can find all of that in the resources section. I also have a QR code if you'd like to give me feedback on how this talk went or if you have any questions. Essentially, this resources page is catered specifically for JavaScript developers. If you are a JavaScript developer, we have a bunch of really interesting recipes that dive into different topics. So running agents to generative search, hybrid search, multimodal search, so searching over images or PDFs, et cetera, et cetera. If you find all of that stuff interesting, I'll show you this one more time in case anyone wants to take that. But thank you so much. I've been Daniel. Also, we have free credits for our sandbox if you want to try us out. If you don't, you can use the open source version also. All these demos were ran using Docker, by the way. So if you go here and look at my, you just scroll to the top. I'm using a local instance and talking to the language models via their APIs. So you don't necessarily have to. But anyway, just mentioning because I feel like it's important information. That is it. Thank you so much for paying attention. And yeah.